You guys ready to go? Okay. I'm going to start with just a little bit of recap, just to make sure that everyone is in a good spot. Okay, so I'm going to give you, this is not reflections yet, this is what we did yesterday. I'm going to give you a couple things. You tell me the shape of the graph and where it would move. Okay? If I give you y equals x plus 1 squared. First of all, what is the shape of the graph?
A U.
It's a U, right? This is a parabola. Why do you know this is a parabola? Because it's squared. Whenever it's squared, it's the U-shaped curve. Okay? Where is this one moving? One left. Okay, one to the left. It's inside. It's the opposite of what you would think. So normally left is subtraction or negative. This is one to the left, positive. Okay, what about this one? Oops. Shape of the graph. This is a parabola, so still the U. Right? U-shaped curve. Where are you moving?
Up 4.
Up 4. Okay, good on that. Okay, what's this one? What's the shape of this graph? It's a line. It's a straight line, right? This is linear. There's no squared here. It's a linear graph, and where are you going? There's no parentheses. So this is outside, essentially.
To the left, down
7 down. Right? So you're moving down 7 on that. What about this one? Y equals x plus 3. Shape of your graph? It's a line. This is linear. And you're going 3 up. Okay? Okay, last one. F of x equals x plus 2 squared minus 6. So this one has 2 parts to it. First of all, what's the shape of the graph? This is a parabola. Okay, and where are you moving?
To the left 6. No, to the left 2 and down 6.
To the left 2, right? This is left 2. And then this minus 6 outside of the parentheses is down 6. Okay? We all clear on that? Okay, then what we're doing today, that's just review. New stuff. We are going to be doing reflections today. And reflections are a little bit tougher than translations because more changes with a reflection. So I'm going to show you the 2 different ways that we will be reflecting. There will be reflections over the y-axis. Is this bad when I'm just writing in green? Like, can you see that fine?
See the color.
It's just the distinguish between colors. Okay, that's fine. I'm good with that. There's no distinction right now. Okay, so a reflection over the y-axis. First of all, I just want you to think about what I mean by that. Okay? If I have a line, like, I'm going to plot some points here. So let's say you have the point 0, -1, and 1, 2, and we make this line. Okay? If I'm going to reflect it over the y-axis, think about what that means. I have my y-axis, that's this one, right? That's the vertical. If I'm going to reflect something over the y-axis, say my line looked like this, when I reflect it, it's going to look like this. Or it looks like this, when I reflect it, it's going to look like that. Think about like I'm folding my paper on that line, and it's a stamp. So whatever's on this side, when I fold it, it's going to stamp onto the other side. Okay? That's a reflection. So when I reflect this over the y-axis, where is this point going to fall? The exact same spot, right? Right where it is. Okay? This point is going to go where? 2 to the left of the y-axis, right? Right now it's 2 to the right, 1, 2. I'm going to flip over the y-axis, so it's going to end up over here. So that means my new graph, when I reflect over the y-axis, is going to look like that. Okay? Okay, so now here's my question for you. What changed about that new graph? Did my slope change? It did, right? It was positive. Now it's negative. Okay? So my slope changed. Did my y-intercept change? No. When I flipped it over the y-axis, the y-intercept didn't move. Okay? So that's what you need to know when you do a reflection over the y-axis. It becomes f of negative x because only my x changes. My y does not. My y stays put. Okay? So you take your function and you do the opposite of the x. What I mean by that, so we're going to say only the slope changes. Okay, my y-intercept stays the same. Just want to make sure I didn't skip any piece. By the way, if you want, there's a picture on page 231 in your book where it like shows you the reflections. If you want to see it moving, you can always take a look at that. Just write it down, page 231. You can take a look. Okay, so your x is changing, your slope is different, but your y-intercept stays the same. Okay, so it's f of negative x. Okay, if we reflect over the x-axis instead, I'm going to draw you a graph of that same line. Okay, so, oh, that's a little lower. So we had a -1, 0, or 0, -1, and we had 2, 0, which gave us this graph. Okay, now think about if I were to fold my paper on my x-axis, that's this one, that's the horizontal. Okay, if I were to fold my paper, think about where this is going to end up. This point right here is going to stay the same. Okay, that's your x-intercept, not your y-intercept anymore. Okay, where is this point going to end up? If I reflect over this line, the x-axis. Well, positive, I only went down 1, so +1, okay, right here, which means my reflection over the x-axis is going to look like that, okay? Now notice what's different. Is my slope the same? No, my slope changed, right? One's positive, one's negative still. Is my y-intercept the same? No, it all changed, okay? So when you reflect over the x-axis, your whole function changed. Meaning your slope and your y-intercept are different. Okay, so the way we think of that is like this. Now instead of f of negative x, it's the opposite of f of x. My whole function got negated, right? So you put the minus, that's the, why do I keep calling it subtraction? The negative in front of your whole function. Okay, do we get that concept? I'm going to show you what that means now. Can I move on? I mean, I'm not moving on. I'm going to show you that now. But I just want to make sure you're caught up with me. Okay, here it is. So this is like example 3, if we're keeping on from yesterday. I'm going to give you a function. F of x equals 3x plus 3. And we are going to reflect that function over the y-axis. Okay. So here's how I need you to think of it. And sometimes the book does it like their new function they call g of x. You may do that if you want. I just am in such a habit of calling a function f of x that I keep calling it f of x. Just understand that it is a new function because we're doing it to, you're going to get a new line out of it, right? But f of x, g of x, I don't care which one you use. If I'm taking this function and I'm reflecting it over the y-axis, look back at what we said, okay? Over the y-axis, you negate your x. You make your x the opposite of what it was. What that means is when I'm looking at this function, I just need to change the sign of my slope, right? My slope is what changed. So f of negative x, okay, if I'm going to reflect over the y-axis, it's going to become negative 3x plus 3. Because when you reflect over y, the only thing that changes is your slope. Okay? So if we graph that, you should have the same y-intercept for both of them. Okay, so I'm going to do this one in purple. Okay, how we graph that? Where do I go first? That's in y equals mx plus b format. So you're going to go up 3. 1, 2, 3 is my y-intercept. Where do I move from there? Up 3 over 1. When your slope is 3, you go 1, 2, 3 over 1, and this would be your line. Okay? If I reflect it, now it's this equation. That one I'll do in black. Okay? So when I do this, my y-intercept is 3, which means I'm at the same y-intercept, but now my slope is negative 3. So what's the difference? What do I do? Down 3, 1, 2, 3, over 1. That's going to put me here, which is going to give me this graph. Okay, I just reflected it over the y-axis. So when you need to come up with an equation, if it goes over the y-axis, this is the only thing that changes. You make it negative. Okay? Questions on that?
So if the slope changes from positive to negative or negative to positive, does the x in f of x change signs too? Because like right now, it's at f of negative x equals a negative 3x.
You're saying if this changes, then this changes?
Or the other way around.
Yes, like that's what's happening to your function, right? It's the opposite of x now. So you put in the negative sign here if this is f of negative x.
But if that's a positive 3x and the original was a negative 3x, would that still be an f of negative x, or would it be an f of positive x?
It would be the opposite of whatever your original was, yes. Because the negative isn't necessarily meaning negative, it's meaning opposite, right? So if it was positive, you're making it negative. If it was negative, you're making it positive. So yeah, when I was doing f of x, now it's f of negative x. Am I answering your question?
Yeah.
Okay. Okay. Another one. You have, so this is B, still example 2. F of x equals negative 2x plus 1. And we're going to reflect, that is an X, not a C. Try that again. Reflect over the x-axis. Okay, so notice this is different now. This is the x-axis, which means we're taking the opposite of the whole function. Okay, so when we reflect it over the x-axis, we want to do this, the opposite of f of x. Well, think about what that means. If f of x is this, the opposite of that means you make everything opposite. So now the opposite of f of x, my new function, is going to be a positive 2x and then minus 1. Okay, so think through this with me. If we reflect over the y-axis, what changes? Y-axis. Just your slope, right? Just this right here, if it's over the y-axis. If it's over the x-axis, which we're doing right now, you change everything. So this was negative, you make it positive. This was positive, you make it negative. Does that make sense? Change everything over x, change just the slope over y. Okay? Okay. So if we were to graph that, and if you are not comfortable with graphing at this point, we really should sit down and talk through graphing, because graphing should be like second nature to you by now. If you're not comfortable, come talk to me and I will sit down with you and we will figure it out. Okay, so I'm going to graph this first function. You have a positive 1 for your y-intercept, and then a slope of negative 2 means I'm going where? Down 2 to the right 1, which gets me that line. Okay? We're reflecting over the x-axis. So now my equation is going to look like this. You have a negative 1 for your y-intercept, which means you're going to go down 1. Okay? And then your slope now is a positive 2. So you're going to go up 2 over 1 and draw that line in. Okay, so that's a reflection over the x-axis. Does that make sense? Yes?
Yes, it does.
Okay. Okay, I'm going to do one more. We're not even going to graph these. I just want to see if you've mastered this over the x-axis versus over the y-axis. All right, let's say my equation is this. F of x equals x minus 7. Okay? If I want to go a reflection over the y-axis, what is my new equation going to look like? F of negative x equals what? Negative x minus 7, because the only thing that changes is my slope, right? When you go over the y-axis. Okay? What if we go over the x-axis?
Same equation.
Not the same. Oh, from this, yes. Starting back where we started from.
Negative x plus 7.
So it'd be the opposite of f of x. And you make everything opposite. So it was a positive x, so now it's a negative x. It was a minus 7, so now it's plus 7. Okay? Does that make sense? They both came from this, right? Make sure you're not saying that this one somehow came from that one. It's not like that. They both came from that first equation. Good? Any questions?